So we're going to talk about some applications involving angles, and we're going to start that discussion talking about arc length. So we have a definition of arc length down here, but let me show you or illustrate for you what we're really discussing when we think of arc length. We have a circle here, and I'm going to put my circle to have some radius r. And let's say that I have this pie shaped right here. So I have this value here, and I'm interested in knowing what is the length of this arc that is contained within this radius of the circle, and we know that this angle here of this pie shape happens to be theta, or we're defining it as theta. So what we're looking at here is this length of an arc that is subtended or intercepted, let's say, by an angle of theta, and we have a circle of radius r. So this length here, the length of that arc, we define as s, and s is made up by taking the radius of this particular circle and that angle of rotation theta. And so we have our formal definition down here. S is equal to r theta. That's how we define what an arc length is. And as we're working through these applications, it's important to note that anytime we're dealing with theta up here, anytime we're dealing with an angle up here, that theta angle must be given in radian measure. So theta must be in radian measure, and we can't use it in the formula if it's in degree measure. So having said that, let's look at a few examples here. The first example that I have says that I have the radius and I have theta. Both of those are known values. It's not clear here, but I do want to know what the arc length is. So if I say S is equal to r theta, this is a pretty straightforward problem in that my radius is 3 meters. Theta is 150 degrees, but don't forget that because we're in degrees here, we now have to convert my 150 degrees into radian measure, which I can do simultaneously within this problem by multiplying 150 degrees times pi over 180. That's the conversion factor to take this from degrees into radians. So I can plug all of that information into my calculator, and if I were to do that, that would just look like 3 times 150 times pi, which is the symbol here above the caret, divided by 180. The decimal representation is just 7.85. That's an approximation because we used the decimal value of pi, but that's what I would happen to be looking for here. If I round to 2 decimal places, I get 7.85 meters. Okay, so that's one way we can look at this. Let's look at another example over here. Here I have the radius of a circle being 14 feet and the arc length 8 feet. So I'm looking for then theta. What would theta be for an arc of 8 feet with a circle of, or with a radius of 14 feet? So going back to our formula, S is equal to r theta, I can plug in my known values. I would have 8 feet is equal to 14 feet times theta. Theta is the unknown, so that's what I'm going to solve for. So I'm going to divide both sides by 14 feet. So I have 8 feet divided by 14 feet is equal to theta. Notice that when I did that division, these units here canceled off. So 8 divided by 14 ends up being 0.57. And I'm in radians. So the difference between this problem and the previous one we worked, I'm solving for theta. Don't forget theta is always in radians within the formula, so therefore this is in radians. So I answered the question that I may have been looking for. We can go one step further if we're asked. Maybe we want to know what is the measure of theta in degrees. So I would need to then convert my radian value into degree measure, so I would now multiply by 180 and divide by pi. So if I go back over here, I would have 0.57. This time I'm going to multiply times 180 and divide by pi. And I'll end up with a degree measure of 32.67 degrees if I were asked. Now the last example I want to work within this section is a little bit more applicable. It says Pittsburgh, Pennsylvania is approximately due north of Panama City, Panama. The latitude or the angular distance, north and south on the equator, of Pittsburgh is 40 degrees north, while Panama City is 9 degrees north. We want to find out what that north-south distance is between the two cities, given that the radius of the Earth is 6,400 kilometers. So while it doesn't seem like it at the beginning, this is in fact a arc length problem. We know that we have the Earth is a circle. We're going to have Pittsburgh, Pennsylvania up here at 40 degrees north, and we have Panama City down here at 9 degrees north. And from the center of the Earth to each of these two cities, we have a constant radius because it's a circle. So the radius here is 6,400 kilometers. I have a degree measure here for Pittsburgh and one for Panama City. I'm looking to find out, the question wants me to find out what that distance is. What's this arc length here? But what I need to know before I go any further is what is this angle of distance, I guess, or rotation from Pittsburgh to Panama City. So I would just need to subtract 40 degrees minus 9 degrees, which is going to give me 31 degrees. So now I have the information, the missing information I need to solve this. The arc length is equal to S is equal to r theta. We know the radius is 6,400 kilometers, and we know that theta is equal to 31 degrees, which we're going to convert into radian measure, or 180 over pi. And now if I were to, just like I did previously, multiply all of those numbers together, 6,400 times 31 times pi divided by 180, I would end up with a distance of 3,463 kilometers if I round. So these are a couple of applications using arc length.